I want to go over the first of our BC only topics. So what does that mean? In calculus and high school level, students are often taking AP calculus, and there's an AP calculus AB, which is what I've been primarily covering, what I primarily teach. Also an AP calculus BC. BC covers actually all of AB and has some additional topics that are not included in AB. And we're going to look at the first one, which is linearization. So what is linearization and why is it useful? Okay, so let me give you an example of a function. So consider f of x equals the square root of, and then let's try x plus 3. Okay, so what does that look like? Okay, we've got some curve here, and your 0 is going to be when x is negative 3. Okay, so say about here, and then it's just going to go up and out like such. Now, what we are going to do is actually consider the tangent line, and we're going to use the tangent line to approximate. Okay, so what's the tangent line? Well, it depends on the point. We know, though, how to get the tangent line, right? We get the tangent line by taking the derivative. So we've got f prime of x equals, and that's 1 over 2 root x plus 3. Okay, there's our tangent line. Okay, so typically in these problems, you're looking at the tangent line at a particular point. And this is where it can get a little bit interesting. So we're going to look at x is 1.1. Okay, so if we go up to x is 1.1, if that's negative 3, 1.1 might be about here. And what we have here is some tangent line. Okay. Now, the idea is the following. The tangent line is close to the curve at points that are nearby. So I mentioned 1.1, okay? That's what we're actually going to be looking for. You could say this is actually 1, and this is certainly negative 3 over here. And then what we're going to do is we're going to use the approximation of the tangent line at 1 to figure out what this function should be at 1.1. Okay? Now, the whole idea of this is that when you put in 1, it's easy, it's 2, right? You get square root of 4 is 2, okay? Whereas 1.1, it's 4.1. Okay, we're trying to do this by hand. So let's put it together now in terms of a problem and see how to actually do it. So what we're going to do is we're going to approximate the actual function. And so we're going to use y minus y1 equals mx minus x1. And what we're going to do is we're going to use this point 1, 2, right? When x is 1, y is 2. Okay? Now, in the linearization approximation, what you do is you're approximating y. And so you really rewrite it as y equals y1 plus mx minus x1. Okay, it's just the equation of a line, but in the literature, it'll often be written as L of x. It's the linearization of x at that point. Okay, it's just a change of notation. It is simply the equation of a straight line. Okay, so now that we have this, what we can do is we can plug everything in using the slope, 1 over 2 root x plus 3, and the point, 1, 2. Right, when x is 1, y is 2. So it's 0.1, 2. Okay, so let's go ahead and do that. Okay, so we've got L of x equals, so y1 is our 2. So we have a 2 here, plus, now what is m? M is going to be this slope, okay? And if we plug in the point 1, because we're using the point 1, 2, right? We're using that line right there. F prime of 1 is 1/4. Okay, so it's going to be 1/4. So we basically evaluate this at the point 1. So you get 1/4. And then I've got times x minus x1, and x1 is 1. Okay, that is the, what? It's the equation of the line, the tangent line at the point 1, 2. Okay, we've done problems like this. The difference now comes into play when we evaluate it at another point. So what we're doing, okay, we're trying to get this point here, 1.1. And the idea is we can't get it exactly on the curve, but because it's close to the point 1, we can use the tangent line to approximate it. And that is what we are going to do. Okay? So to get that, what we need to do then is simply plug in what? What are we plugging in here? It should just be 1.1, what we want. Okay, so L of 1.1 is 2 plus 1/4 of 1.1 minus 1. And then let's go ahead and do the computation to figure out what this should be. Okay, so L of 1.1, sorry, the little one here and turned it into a point. Try that again. L of 1.1 equals, okay, so here you have 0.1, which is 1/10, and that's going to be 1/4 times a tenth is 1/40. Okay, so you get 2 1/40, right? So it's 2 1/40, which equals, 81/40. Okay, and what you will find, well, that's 2, right? With, in effect, did I write 81/40? Yeah, it's 2 with 1 left over, and 1/4 is like 0.25, so it's 0.025. And so we get that this is 2.025. Okay, and I will tell you, so if you plug into a calculator, f of, say, the square root of 4.1, and you round it to 3 decimal places, that's what you actually get. You get 2.025, I think it's 2.02484, something like that. So it's a really good approximation. Why is it a good approximation? It's a good approximation because 1.1 is close to 1. If you're trying to approximate, say like the number 3, it's going to be a poor approximation because they're going to be too far apart. So this is the whole idea of linearization. You basically simply take the tangent line at a particular point, at a convenient point, at a point that's easy to plug in, like the 1, 2, and you use that, this is the new part, you use that to approximate a new point. So what we're doing when we plug in the 1.1 here, it's not on the pink curve, it's on the green tangent line. We just use that's the green tangent line, but when you plug in 1.1, they're very close at that point, okay? To get the hang of it, let's try maybe another example. Okay, so sometimes you might just need to approximate something. And so here's the example. Okay, we are going to approximate the square root of 17. Now, we're going to do that using the same idea. So you can think about how you might do it, okay? What should our function be? Da, da, da. Okay, let's think about that one. So clearly the closed function that's nice is the square root of 16, right? So that's the nice one. Now, if we look at the one that we just did, okay, The nice one was we put in 1 and we get 4. Okay, so what we need to do is come up with an alternative function, okay, where if we plug in a value, and you could just, you know, the key is, there's not one way to do it, but it's kind of nice if you just sort of add 1, okay? That's a simple way to actually do it. Let's show you what I mean. So let's try, well, how about let's just do it like this. Let's do x plus 4. I'm sorry, 16 plus x. I think that's what I meant. Okay. And again, different ways to do this. Why am I choosing 16 plus x? Because we know what the square root of 16 is. Okay, so we do x plus 16. And what we're going to use now, you know, the visual can be helpful, but you don't necessarily need it. What we need is a convenient point. We've got f of 0 equals 4, and we can use that now to get our slope. So we've got y, instead of doing minus y1, you can say equals y1, y minus y1 equals m, so it's a plus x minus x1. Now, we've got to get our m here, okay? So this is our linearization. Okay, we've got our x1, y1. We still need to get our m, and we get that with f prime of x, and that's pretty straightforward because it's just 1 over 2 square root of x plus 16. And when we plug in 0, we get 1/8. So the linearization, just changing this y to L of x, either way is okay, is going to equal, okay, y1 is 4, plus m, we're plugging in at 0, so that's 1/8. And then I've got x minus, it's actually 0, but I'll go ahead and write that in, x minus 0. Okay, so that is our equation, that's our linearization. Now, it gives us the tangent line at the point 0, 4, okay? And what we're going to figure out is what now the square root of 17 is by making x equal to 1, right? So L of 1, y1, because that will make this root 17. And so we get 4 plus just 1/8, and that equals, what does that equal? 33/8. I mean 4 1/8. But I say 4 1/8 because if you want to get the decimal expansion, you know your 1/8, it's I believe it's 0.125, and so we get that this equals 4.125. Okay, so it's not bad. I can tell you this one is 4.123. So what's the difference? It's not really from the choice here. It's that if you choose the square root of 17, you're one whole number removed from 16, whereas in this case we were looking at, we didn't really write it up, but it was like 4.1. You can approximate the square root of 4.1. This is what we used, and it's only 1/10 away. So this is one whole unit away versus 1/10 away, but you can see there's still like really good approximations, especially to a couple of decimal places. So this is how linearization works. It is simply estimating points on a curve by using the tangent line and picking convenient points that are close to them.